Hello and a very good day. Welcome to the webinar. My name is Abhilash and I am from the AD Solutions team here at Manage Engine, and I would be your presenter slash speaker for today. Now, before we go ahead and jump in, I would like to thank you all for joining in. Thank you so much for taking out the time. Now, I understand that these are troubled times because of the pandemic and everything, and I hope all of you are indoors and safe. Now, before we go ahead and jump into today's webinar and see what's in store for us, I would like to run a quick audio and a video check because I want to make sure that everybody out here today are able to hear me and are able to see the screen well. So I'll quickly start off with an audio check. So if you can hear me, if my voice is reaching to you well and clear without any distortion in the audio, can you please use the Q&A tab in front of you and give me your confirmation, please? Just say yes, just say okay, just say great, so I can confirm that the audio is reaching to you well and clear. Thank you, James. Thank you so much for your response. Now, I hope the video is clear as well. I hope the title and my email are visible. Could you give me just another confirmation for that as well? Thank you so much, James. Thank you for your response. Thank you, Mohammed. Thank you, James. Thank you for your responses. Yes, looks like we are good to go. But before we begin, I would like to tell you that the entire session happening today and will be recorded, and the recording would be sent to you on your email post the webinar. So if you've got any questions during the course of the webinar, please feel free to use the Q&A tab and keep your questions coming. And the last 10 to 15 minutes of the webinar session, I will be answering your questions. And if you have any questions that you would like to ask me or anything on your mind regarding the webinar or the solution showcase today later in the day post the webinar, please feel free to drop an email to me at abhi@manageengine.com anytime, and I'd be more than happy to help you out. All right, so with all the housekeeping stuff out of the way, let's go ahead and jump in and see what's in store for us. So the topic for today's webinar is identifying security misconfigurations that can lead to breaches. Now, the whole reason I chose to speak about this topic today, the whole reason I chose this to be my agenda today is to shed light on an important factor. Now, we are reading about security breaches that are happening. The recent Twitter breach, for example, where hackers were able to tweet out cryptocurrency scams from accounts of many celebrities such as Elon Musk or Apple. So whenever such breaches happen, whenever such high profile or highly devastating breaches happen, we focus on that, which is good. And we tend to look at the bigger picture. We tend to see what got affected. We tend to see the losses that the company incurred because of the breach. But the important thing that we often tend to oversee is the simple misconfigurations, right? The simple security misconfigurations, the simple management mistakes, the simple administration errors that either were the reason for the breach, that either caused the breach, or even helped in the spread of the breach, helped promote the breach. So that's going to be the focus of today's webinar. We will take a look at the breaches that happened in 2020, famous breaches like the Twitter breach or the San Francisco airport hack. And we will see how simple security misconfigurations could have led to the breach. And we'll also learn how we could identify such security misconfigurations, such administration mistakes and errors, and fix them in time to ensure that we are not subject to a breach such as this. All right, so let's take a look at what security misconfigurations are all about. Now, like I said, whenever we speak about breaches, we tend to see the losses that were incurred. We tend to see the scope of the breach. We tend to see what the breach affected. But the major reason that breaches happen is because of simple misconfigured security controls. So a security misconfiguration is essentially the failure to implement sufficient security protocols or regulations, or the protocol or the security regulation has been implemented, but has been done with errors, right? That's the simplest meaning of a security misconfigurations. Now, misconfigurations are extremely difficult to discover because most organizations, most enterprises, most small to medium businesses think that their infrastructure is solid, their infrastructure has no misconfigurations whatsoever. But once an attacker, right, either external or an internal malicious user, discovers a small misconfiguration, discovers a wrongly assigned permission, for example, he or she can leverage that misconfiguration, can leverage that permission, and it's only a matter of time before your network security is put under danger, is put under risk. All right, so the basics, security misconfiguration is the failure to implement something, implement a security regulation, or you've implemented security regulations, but you've done it with errors. Right, so let's take a look at 3 top reasons misconfigurations typically occur in organizations. One is the default settings that come in with your infrastructure. Let's say your Active Directory infrastructure, right? You have your accounts, your administrator accounts that you use to configure all the servers in your user accounts. This is the default account that comes in, right? So you do not disable the administrator account. And number 2, the password of the administrator account is not changed for a long time because it's a local administrator account. Nobody bothers changing the password of the local administrator account. And number 3, the passwords for local administrators are often repeated across multiple nodes in a network. This is a classic example of how default settings that come in when we initially configure our IT infrastructure are left untouched or are left unchanged or not updated. Right. Number 2 is unrevoked permissions. Now, permissions are assigned to end users in an organization, either when they need them or because there was a role change or for temporary reasons. Right. But the problem is permissions once assigned are seldom revoked. For example, if a user calls up and requests an administrator or a help desk technician to give him or her access to a particular file or folder, right? A simple read access. Access is given to the user, but the problem is because of access modifications that happen all through a user's lifespan in an enterprise, an administrator or a help desk technician may forget to revoke the granted permission. That's the second reason misconfigurations occur, unrevoked permissions. The third reason is vulnerabilities that come with platforms, right? Be it Active Directory, be it Azure Active Directory, be it the password policies that are configured in your domain. There are certain default vulnerabilities that come in with platforms that are not yet fixed by companies such as Microsoft, and they can lead to a security misconfiguration, which in turn could lead to a breach as well. Right? So let's take a look at how misconfigurations or how security misconfigurations can lead to devastating breaches in organizations. Right? So we will be taking a look at 3 to 4 real world breaches that have happened, and we'll drill down, we'll go behind the curtains, we'll go behind the scenes, and we'll see how exactly the breach happened and what was the reason behind the occurrence of the breach or even the spread of the breach. Right? So first up, we've got the NTT Active Directory server hack. So how did this happen? The NTT Active Directory server hack was a very devastating breach that happened just 2 to 3 months ago, where an attacker got access to an endpoint, as you can see here, in Singapore, and the attacker was able to move from the endpoint to a cloud server, from the cloud server to an internal server that was in close proximity to an Active Directory domain controller, and eventually the attacker got access to the Active Directory domain controller, where he or she was able to siphon out details of more than 600 employees. Right? So this is how it happens. A small endpoint, a single endpoint compromised in an organization can lead to access to a domain controller. That's how the NTT Active Directory hack happened, right? So let's take a look at how it could have happened and how it could have been prevented. So Active Directory, right? I have been talking about Active Directory. I have been talking about Azure. I have been talking about cloud services, but now the truth is Active Directory is still a prime target for most security breaches. The NTT server hack is just the proof. Right? Because why Active Directory has been around for a long time. Active Directory has been the prime mode of authentication and authorization for many organizations. Workstations, your end users, your member servers are all managed on premises in Active Directory. Your security policies, your logon rights, your group policies are configured in Active Directory, right? And the truth is, Although cloud services are being adopted, cloud services like Azure Active Directory are being adopted. Active Directory has been around for a long, long time, right? So organizations have not yet given up on Active Directory, but they are adopting a hybrid infrastructure, which is a combination of Active Directory and Azure Active Directory or any other cloud service. But the truth is, because Active Directory has been around for such a long time, it is a prime target of most attacks, right? And 90% of businesses are subject to security breaches because their Active Directory is mismanaged or not managed securely, right? So the first step of the entity server hack was an endpoint compromise. Right? So this is what happens in Active Directory environments. An endpoint is compromised, malware is installed, or a malicious program is installed. And once an attacker has initial access, he or she can perform reconnaissance or domain surveillance to understand where the targets are in an Active Directory environment. For instance, members of domain groups or location of critical servers in Active Directory environment, and the attacker would move laterally to gain complete domain dominance. Right? So the problem here is the initial access to the endpoint and establishing command and control. Once the initial access is obtained, it's only a matter of 7 minutes before an attacker can become a domain administrator. These are stats that are not said by me, but these are stats that are quoted by Symantec. Right? So the first step, the endpoint takeover. If you can recollect, in the entity security breach, the first thing that was happened was the endpoint takeover. So we're going to try and take over an endpoint in a typical organization that has Active Directory, right? Because it is an Active Directory server hack. Now, endpoints are a prime target whenever it comes to gaining the initial access or passing the initial infection phase, because endpoints typically have weaker security regulations. They do not have privileged access. Endpoints do not have privileged access, yes, but they can be leveraged to cross the initial infection phase. Right? So endpoints are poorly protected in organizations. They have weaker security regulations. So it's impossible for an attacker to gain admin access by just logging onto an endpoint. But then again, endpoints are a good start to understand from where the attack could be further propagated, how to laterally move in an organization, right? So the endpoint takeover, the first thing we are going to do is to try and look for misconfigurations in an organization, right? So let me just propose a simple way attackers can gain access to endpoints in your network, right? So I have group policies in my organization, everybody does. And if I head into my group policies, and you can see that there's something called guest account status here, right? This is disabled, but in some organizations, guest account status is enabled. So let's assume that guest account status is enabled. And once that's enabled, let me show you something else, right? So if I scroll down, you will see something called do not allow anonymous SID or name translation, right? So I will tell you what this is shortly, but let's just enable it. And once we're done enabling it, let me show you what happens, right? So with guest access enabled via GPOs and with anonymous SID name translation enabled, an attacker can log on to an endpoint, right, without having to give in a password, because, well, guest access is enabled. All the attacker has to do is give in the guest username, hit enter, and he or she can log on, and then he or she can acquire privileged user details. So this is how it's going to work. If I head on to my VM right here, and here you go. So I am in my VM, and let me quickly show you something right here. If I open up my command prompt, right, you can see that I've run a command here that says WMIC user account get name, SID. It's just a simple command I ran as an end user with no privileges, and I was able to find out all the accounts in Active Directory and their respective SIDs. Right? For those of you who do not know, the administrator account in Active Directory always has a SID of 500. That's right, this is a standard in Active Directory. What most organizations do is to mask the administrator account. They rename the administrator account, but as an attacker with sufficient knowledge, I was able to understand that even though the administrator account could have been renamed, the SID will always be 500, right? So that's my point here. with misconfigured group policies such as guest account enabled and allow SID name translation, I was able to log on to an endpoint without entering a password and acquire privileged user details. For starters, who is the administrator of the Active Directory environment? Right now, once I have sufficient information and with the initial access obtained with the guest account, with the guest user account, I can perform a simple password spray attack. Right. So let me quickly show you how that works. If I head on to my VM right here, all right, you can see that I have a script here. Just a simple script that we made up is just a script to perform a password spray attack on your end users. So this is how it's going to work, right? So if I open up PowerShell, now I see that some of you are having audio issues. I apologize for that. I'm trying to get that fixed on my end. Here we go. So let me quickly open up PowerShell. As you can see, I've done here, right? And let me increase the size so you can view this better. I'm going to head into properties and I'm going to increase the size to, let's say, 18, right? So once that's done, I have a script here called the domain password spray script that we are going to use. So here's what I'm going to do, right? I'm going to type in net user ROS just to show you ROS's privileges in the organization. So ROS is the logged on user and these are ROS's privileges, right? So what I'm trying to say here is that ROS is not an administrator or a privileged user of any kind, or at least that's what Active Directory tells me, all right? With that out of the way, let me clear this and let me head to the desktop. And now let me run a command called PowerShell.exe-exec and then bypass. With that done, all right, looks like there was a little typing error here. And here we go. This will allow me to execute any script that I want, regardless of whether it's verified by Microsoft or whether it's signed or authenticated by an authorized source. So that's the first command that you'll have to run to bypass PowerShell rules. And now let me quickly run a command called import module /domain password spray.ps1, right? Pretty straightforward. I've imported the module that we just saw and invoke domain password spray. I'm going to give in a password, right? Just a standard password, nothing fancy happening here. I'm just going to give in a password that is still used in most organizations, and that's password at 123. And once I hit yes, you can see that within, let's say, a few seconds, I've got usernames and their potential passwords. Right? Now I could try a list of passwords as well, like admin at 123 or your organization's name at any number. The list simply goes on, and this is how I can obtain users and their passwords, their plain text passwords. And this is how initial access can be obtained, right? A simple misconfigured GPO, guest account access enabled, got access to the endpoint, allow anonymous SID name translation. I was able to find out who my admins are or who my users are or the usernames of my accounts in Active Directory. And with these simple GPO misconfigurations, I was able to launch a password spray attack on the accounts that we just found out by enumerating their SIDs. And within a few seconds, we have access to the accounts. Right now, one thing I didn't mention is that the administrator account, the account with the SID 500, is the most targeted account in most password brute force or password spray attacks. Now, the reason I say that is because administrators' accounts, they have no lockout policy. Right now, I'm pretty sure you would have heard of the lockout policy on your domain, where you set a threshold for your user accounts to be locked out, right? It's either 5 or it's either 10. So if a user enters a password wrong for a fixed number of times, the account would then get locked out. But this is not the case with the administrator's account, because the lockout policy cannot and does not apply to the administrator's account. So you could potentially try how many ever passwords you want. You could potentially brute force how many ever passwords you want on the administrator's account, and the account would never get locked out, thereby not raising a risk. Right? And the fact that the account always has a SID of 500 makes it a go-to choice in most attacks. So that's how initial access can be obtained, right? A simple GPO misconfiguration, a password spray attack, and of course, you could create malicious macros and subject your user accounts to phishing attacks as well, right? So I've created a few macros right here. So these are a few infected macros that I was able to create with just a PowerShell script. Again, nothing fancy happening here. In this case, if I open up this macro, you can see that the calculator opens automatically, but this is just an example that I wanted to show you. But the truth is this application right here could be a backdoor malware application that could register itself in the registry or could create a custom task using the task scheduler. The list simply goes on. Right, there's another way initial access can be obtained by a classic phishing attack. But now let's move to the next part of the attack. We've got access to the endpoint, right? And what can we do from the endpoint? We try and understand what the status of the domain is, the location of target rich users or servers in an organization can be queried and can be obtained from an endpoint in an organization. Sadly, that's how Active Directory is designed. That's the architecture of Active Directory. So let me show you a quick example right here. If I head on to my VM, and here you go, let me clear this, right? And let me run a command called get AD group member, and let's just call the group identity administrator, right? And within a few seconds, just a few seconds, I've got all the members of the administrators group. A pretty handy command for a password spray attack or for a spear phishing attack if you were planning to do one. Right now, let me show you something else. If I head on to my command prompt right here, you can see that I've run a command here called nltest dclist wsmbda.com. WSMBDA is the name of my domain, and running this command will let me know what the domain controllers are and where they are located, which site the domain controllers are located. As you can see, I've just got one domain controller, and that happens to be a primary domain controller, right? There's a lot you can do with access to an endpoint. For example, if I type in get AD default domain password, right? You guessed it, I was able to find out the password policy of the domain, which is again pretty handy if I'm planning to do a password spray or a brute force attack. I can fine tune my brute force attack so the attack doesn't last for more than 10 attempts in this case, thereby not locking out any account, thereby remaining stealthy as possible for as long as we can. Right? So that's my point here, initial access to the endpoint, and from the endpoint, you can find out who your admins are, you can find out the location of critical servers, you can basically perform footprinting or surveillance to understand where your targets are. Right? Here are a few commands that you could use as well, just with internal tools like PowerShell or command prompt. Now the next step, we compromise the endpoint, right? Now in the NTT attack, the attacker went into a cloud server, and from the cloud server, the attacker moved on to an on-premises Active Directory server. But let's see a simple scenario in this case, right? Let's see how in typical organizations, once access to an endpoint is compromised, the attacker could move to a domain controller. That's what we're going to look at, because this is the typical attack scenario in most organizations, right? So how can an attacker obtain access to the internal server A, which is in close contact to the domain controller from an endpoint? Right? Now let me show you a quick example right here. If I head on to my VM again, all right, and let me clear this. And if I minimize this, you can see that I've got Mimikatz here. Now Mimikatz is a tool that most of you should be aware of, and most antiviruses do detect this tool, but it can of course be recoded, it can be re-engineered, so antiviruses will fail to detect it. So let me show you something right here. This is Mimikatz, and I copy the path, right, and I paste it, as you can see I've done here, and I launch Mimikatz, right? And now I'm just going to type in a simple command, which happens to be LSA dump DC sync, right? I'm going to give in the name of my domain, which happens to be wsmbda.com. And I will give in the name of my user, which happens to be, let's say, an administrator, right? And within a few seconds, just a single command, I was able to get the hash or the password hash of the administrator account. Now, what can I do with the hash? I could use the hash to create a remote PowerShell session and log in to a domain controller from the administrator's account, or I could simply copy the hash, head on to my browser here, right? And I will open something called CrackStation. This is a password hash cracking tool, a free tool available online. I just paste the hash, and once I hit crack hashes, you can see that I have the password hash right here that we just pasted and the user's password. Right? The user happens to be an administrator. So how did this attack happen? The reason this attack happened, the reason Ross, an end user with no privileges, was able to query for domain administrator password hashes was because of these permissions. So let me head on to my VM right here, open up my ADUC console. I'm pretty sure you would have worked with this. This is my domain node, right? I click on it and I head into properties. All right, so let me quickly hit the advanced features. I click on it, head into properties and security. And I hopefully should find my user Ross right here. Right, so here we go, got my user Ross right here. And if I scroll down, you can see that Ross has these privileges: replicating directory changes and replicating directory changes all. Right now, these privileges are used in domains, basically between domain controllers, to update each other of the changes that are happening in Active Directory. So if a user updates a password, the domain controller uses an account with these permissions to update the other domain controllers in an organization, right? So that's the reason these permissions are actually used in Active Directory environments. But in this case, Ross has access to these permissions. How did this happen? The reason this happened was because of this, right? So let me open up PowerShell again and let me run a command called net user Ross, right? Just to see what Ross's group privileges are. And you see that Ross is a member of a group called Exchange Windows Permissions, right? This group right here called Exchange Windows Permissions, as you can see right here. And the member of it is Ross. Ross has access to this group, and this group has write access on the domain node of the organization. So any user who's a member of Exchange Windows Permissions, in short, has access to the domain node in the organization. And that's how Ross was able to assign himself or any other user, if you wanted to, the replicating privileges in Active Directory. Right? And that's how Ross was able to get administrator password hashes. So what is the misconfiguration here? Was it the replicating directory changes permission assigned to Ross? Yes, but the truth is the misconfiguration here was the group membership. Ross somehow got access to the Exchange Windows Permissions group, and that's how this attack happened. If Ross hadn't gotten access to the Exchange Windows Permission group, this attack would have never happened, because Ross will not have the required access to modify permissions on the domain node and give himself these permissions. Right? Now you could use the same attack to get the ticket for the KRBTGT account. This account in Active Directory, as you may already be aware, is used to create tickets in Active Directory for all accounts in Active Directory. So if a user, if Ross is able to get the hashes of the KRBTGT account, he or she could potentially create a fake ticket for any account that he or she wants. It could be an administrator account. It could be a privileged user account. And he or she could log into the domain, and you know the rest of the story. Right? As you can see in this image right here, Ross initially never had access to this particular share. But when Ross got the permissions, right, the permissions of the KRBTGT account, Ross was able to forge a fake ticket granting ticket to gain access to the share, as you can see here. So this is another way the DC sync attack can be exploited. Have you heard of this permission on your computer nodes? It's called trust this computer for delegation to any service. Right? So let's say the compromised endpoint that we just compromised has this particular permission enabled. right? So if this particular permission is enabled, as an end user, I can somehow socially engineer or ask a domain administrator to log on to my system for some reason, right? I could call the domain admin and say, hey, there's something wrong with my system. Can you please log on to it? And the domain admin would log on to my system, and the domain admin's password hashes will be dumped into my local memory, my LSA. And once that's done, I can get the password hashes of my domain admin again, right? And the misconfiguration here is this particular option. Whenever a computer is trusted for delegation, the computer will automatically store all the credentials that are used to connect to it in the local memory. And those credentials can be obtained by using tools like Mimikatz. The hashes can be obtained and you can log in as a domain admin, or you could even remote into a domain controller just by using the hashes that are obtained. As you can see, the system here has trusted for delegation true, and that's how I was able to remote into another domain controller, because now I have access to a domain admin's password hash. Right, now let me show you another quick example right here. So this is an example of a DC shadow attack. So let me quickly head on to my VM right here. All right, and let me close this as well. And you can see that I've got Mimikatz here. Again, you can re-engineer the tool so it remains undetected by your antiviruses. And I right click on it and click on run as administrator. Under the logged on users context, and here we go. That's done. Now let me show you what happens here. If I run a command called privilege debug process run p, I can now launch a console under the system administrator's token, right? As you can see up down here. And now I will run a command which happens to be lsa dump DC shadow, and I give in stack. My object here happens to be normal. Normal is the name of my object, and I give in an attribute that I wish to modify, which happens to be the description attribute. It could be any attribute. It could even be a group membership or a password flag attribute. And I give in a value, which happens to be, let's say, I was here. Right? I hit enter. With that out of the way, I type in lsa dump DC shadow again. Right? And now I head back to my older session and I type in a command called lsa dump DC shadow, and I hit push. Right? Now I'm not going to say anything. Let me show you what just happened here. If I head on to my VM, and you can see this is my ADUC console, and I look for my object, which happens to be my normal object, right? Normal is the name of my object. I open it up and look at the description. I was here. Right? So if you haven't guessed it already, this was an attack where I was able to add an endpoint as a rogue domain controller, right? And inject changes into Active Directory from the rogue domain controller. And once the changes are injected, I was able to unregister the domain controller, unregister the rogue domain controller, thereby making this process extremely invisible. So how do we track this? How do we track this particular change, right? How do we watch this attack? So let me show you what happens when a client system is registered as a rogue domain controller. If I head on to my browser right here, head on to AD Audit Plus, this is our solution, right? So we are talking about Log 360 today. And for those of you who are not aware of Log 360, show you what it is. So Log 360 right here. So this is Log 360, a combination of multiple auditing and monitoring solutions for your on-premises and for your cloud environments like Azure, AWS, or Google Cloud. But for this webinar, we will be talking about two main components, which is AD Audit Plus and Active Directory, a hybrid Active Directory auditing tool, and Event Log Analyzer, a log management and a monitoring solution. right? So these are two things that we're going to look into, and let me show you what caused the DC shadow attack. So if I head on to reports right here, you can see Active Directory, and if I scroll down, you will find computer management right here. If I head into recently modified computers, you can see that my computer Abhilash has been modified, and if I click on it, you'll see the user Brad, with whom which is logged on, right, made changes on this computer account. What was the change? Let's take a look at the computer old and new attribute values. So here we go, Abhilash, Brad, and the old value happened to be this, right? And the new value happens to be a service principal name. So whenever an endpoint is promoted as a domain controller, either temporarily or permanently, the endpoint will be given the service principal name attribute, right? Without adding a service principal name, the endpoint cannot be promoted as a domain controller. And that's how the attacker was able to inject backdoor changes into Active Directory. Right? And that's how AD Audit Plus can help, because AD Audit Plus monitors your Active Directory objects real time and shows you any changes on them if there were any. Right? So this particular change can be set up as an alert. So if I head into configuration, create an alert profile, I can set up an alert for that particular attack alone, where I can notify the admin via email, via SMS, and also execute a remedial script, a corrective script to basically terminate the user's session or shut down the user's system, right? So this is how the attack happened, and that's how AD Audit Plus can help by watching changes to your Active Directory objects, by monitoring changes real time and alerting on them. This is just another example where you could create a dynamic group in Active Directory and inject backdoor changes. Now, the beauty of this group is that when you create it, it can be added to any administrative group, but after the entry TTL expires right here, the group will vanish from Active Directory, right? Leaving no trace in the event logs. So most attackers use this group to inject backdoor changes into Active Directory from an endpoint machine as well. Right? And AD Audit Plus will help you track this group by looking for the entry TTL attribute, right? So all you got to do is head into your group management right here, and whenever head into group recently modified groups, and whenever the entry TTL attribute is added to a group, the AD Audit Plus will produce an alert right here, and you can set up a customized alert if you want to as well, right? So there are many other ways an endpoint can be used to gain access to a privileged server or even a domain controller, and these are just a few examples. From the unconstrained delegation, right, the second use case that we just spoke about right here, where the hashes are dumped to the local memory, those credentials could be taken and could be played on a domain controller to gain access to the domain controller. Because if you can recollect, I said earlier that most default settings, such as local administrator passwords, are not updated in organizations, and that's how attackers can find a particular local administrator passwords and replay that across nodes. The rogue domain controller that we just added can be used to add backdoor administrator users in Active Directory, thereby achieving persistence. And the third one was a SID history attribute, right? You could add an administrator SID to an end user in Active Directory, and those changes could be done stealthily as well. So if I add the SID 500 to one of my end users, the user would be a secret administrator in my Active Directory. Right, so that concludes the NTT server hack. We saw how we could move on from an endpoint, and from an endpoint, how we could recon for things. And after performing reconnaissance, the different ways we can obtain domain admin access to a domain controller. Right, and this is how Log360 can help. Let me quickly show you how Log360 can help you. If I head into Log360, do you see something called user logon reports here? This will show you all logon failures in your organization, right? This report is extremely useful when it comes to password spray attacks or when it comes to brute force attacks using scripts. Because if you find logon failures for an admin user or for any user for that reason, it will automatically show up here, and it will of course produce an alert send you an email, send you an SMS, so you know whenever there is a brute force logon attempt or a password attack attempt on your administrative users. Right? So that's use case number one, the password spray attack that we performed. That's how it can be tracked with Log360. Right? And if we have to analyze this a bit further, if I head into server audit, we've got something called PowerShell auditing right here that you could potentially use to audit for scripts that are run by your users. As you can see here, my user Ross has run many scripts, and these are alerts for the scripts that are run by Ross, right? And if I further head here, or if I head into script block logging right here, this will show me all the scripts that Ross ran within a given period of time. I could go back in time as well. And if I click on details, I can find out what the script contained as well, right? So this is advanced analysis for you to find out if your users are running malicious scripts. So for the password spray attack, the logon failures report would do, but you can also head into PowerShell auditing and set up PowerShell auditing to ensure that you track users who are running malicious scripts. Right? So that's use case number one. The other use case was reconnaissance, right? We performed reconnaissance from an endpoint where we queried information about security group members, the location of servers, the domain controller name, the password policy, and so forth. And in order to detect that, we've got something called LDAP auditing right here. So if I head into LDAP auditing, head into, let's say, recent LDAP queries, this will show me all the queries that were run by my users. Right? So this was by an administrator, so everything is safe. But if another user has run LDAP query commands right here, for example, to find out members of admin groups or find out the password policy, it could be a malicious attack attempt. And we can find that out with LDAP auditing right here. We can find out reconnaissance or surveillance attempts with LDAP auditing right here. And of course, you can set up an alert for that as well. Right? Registering a rogue DC, we just spoke about it, where you have to head into the computer management and check if an endpoint has been given, if an endpoint machine has been given a service principal name, because that's how computers are promoted as rogue domain controllers, right? And this is how Log360 can help by tracking all of these changes for you, showing them to you in the form of a report, alerting you when you're aware, and also setting up a mitigation action. For example, a script can be configured in Log360 to basically terminate the user's session or disable the user's account, right? Now, I also spoke about something called password hashes that are written into the memory when Kerberos constraint delegation is enabled. And you can track that with these logs in your Windows event viewer. So as you can see, the LSASS has been queried, right? And certain processes have been used to query the LSASS, and you can use Log360 to search for your logs and configure customized alerts as well. Right? So this is how it's done. You can see event ID is this, and if the object name contains LSASS, meaning if any query has been made against my local computer memory, you can throw an alert, right? So that's how this works, and let me show you how that's done. Which for that, we'll head into the other component of Log360, which is Event Log Analyzer. I head into search, where I can search for events, and not just that, I can set up customized alerts right here. All I got to do is head into advanced, as you can see here, and I can set up customized alerts. So let me show you how this works. I refresh this, log back in, head into reports, head into search. I pick a device, which happens to be, let's say, my DHCP Windows server, and I click advanced, and I can set up an alert based on certain patterns within your event logs, right? So that's how we were able to track LSASS dump attempts with Log360, and that's how it works. Number two, something we can never forget is the ransomware attack attempts that have happened in 2020. The snake ransomware has gained popularity. There is the coronavirus ransomware that has been gaining popularity. But whenever it comes to ransomware attacks, there are a few standard things that happen, right? Endpoint compromise by any of the attack methods that we discussed all this while. Changes to folders where, for example, critical configuration folders like your C or your system root folder has changes made to it, or there are changes to your domain policies, or there are new services that are being installed, or there are processes, certain hard-coded processes that are shut down immediately because the ransomware has gained entry. So backup processes will be shut down. Any backup copies, your volume shadow copies that you've configured in your domain will automatically be deleted. All your files will be encrypted and they'll be renamed to the ransomware, whichever it may be. Right? For example, if we speak about the Snake ransomware, point of entry happens through insecure remote desktop credentials. Right? An insecure, exposed, or an attacker has logged on from a remote system onto your domain. That's how the point of entry happens, right? And a list of hard-coded processes are killed. There are many processes or services that the ransomware kills. It makes WMI calls to all the nodes in the network, and then it creates, right, these particular folders or files within your domains group policy or your sysvol folder to propagate it to other nodes in the network. This is how the Snake ransomware attack works, right? And if we look into the coronavirus ransomware attack, you can see that it copies itself with a random name to this particular location. It sets a registry key under this particular run key. So whenever a user logs on to a system, the ransomware will be executed because it is configured under the run key. Just like Snake ransomware, it deletes all backups by running this particular command quietly. So all your volume shadow copies, all your backups will be deleted, and then it starts encrypting files, right? Renaming the extension to this. So Log360 can help you with this because Log360 can help you monitor your critical system processes as well. For example, if your systems are being shut down or started continuously for many times, it could be a potential ransomware attack attempt, right? Or it could be a user trying to force boot himself or herself into the automatic repair mode in Windows to reset his or her password. So changes such as that, anomalous changes to your Windows ecosystem can be detected with Log360 when new services are installed, when registry key changes are made. For instance, the coronavirus ransomware attack makes key changes to this registry. When files or folders are modified, as you can see, I have an alert right here for whenever file or folders are modified, right? So let me show you something right here. If I head on to my VM and head into file audit right here, right? So I've got file audit reports here across all my file servers, and not just across my file servers, across my connected member servers as well, right? So whenever files or folders are modified, right? If I head into this and let me show you something right here. All right. Okay, so whenever my files or folders are modified, whenever my files or folders are changed, when they are renamed, when they are created, when they are deleted, right? I want to know when that happens. These changes are especially useful for you in order to track ransomware attack attempts and also to block the ransomware attack before it reaches your other nodes in your network, right? And Log360 can help you with that because Log360 can track your file or folder changes. And of course, Log360 can track scripts as well. Ransomware attacks execute scripts to shut down processes or to make new service installations or to stop services or to delete your backup copies. So for all of these ransomware attacks use scripts, and with Log360, you can track the scripts and you can set up alerts as well, right? And not just that, Log360 is capable of building correlations. As you can see, I've built a correlation right here. So whenever a file is created, whenever a process is started, whenever a file is deleted, whenever a set of files or folders are renamed, whenever my backup copies are deleted, I can configure an alert using correlation rules in Log360. As you can see, this is a correlation rule that we've already pre-configured in Log360 to detect coronavirus ransomware attacks. When it finds out any file if they've been renamed, it finds out if shadow copies have been deleted, and it also finds out if there are many files being encrypted or the extension of the files has been changed or a marker has been added to the files in multiple DCs or your member servers. Right, so all your critical Windows changes that could link to a ransomware attack can be detected, and you can build correlation rules for specific ransomware attacks as well. Right, all you got to do is configure the correlation rules, set up an alert, and you're good to go. So the third attack we have here is the San Francisco airport attack. Now the San Francisco airport attack was San Francisco airport websites There were two websites, sfoconnect.com and another, and both of them were subject to an attack where the attackers were able to gain access to the credentials of the employees working in the airport. And the reason this attack happened was actually a very, very simple attack that has been coming along for many, many years now, right? And the attack abuses the SMB protocol or the SMB relay protocol. This is how it works, right? So let me head on to my VM. And if I close this, you will see that I have a script here called inway. Right? So let me run that script for you and show you what it actually does. I click on this, hit properties, and increase the size so you can view this better. Here we go. And now run the initial bypass command that we have to. Once that's done, I will shift to the desktop and I will run a command called import module.inway.ps1, right? The inway script that I just showed you right here. Once that's done, I'm going to run a command called invoke inway, and I'm going to run a command called console output yes and nbns yes. And once I hit enter, here's what's going to happen. Right? So what the script does is it listens for requests on the domain. So if as a malicious end user or as an attacker with access to an endpoint, I run the script, right? What I will be doing is I will be listening for any NBTNS or NBNS requests. So what is NBNS? Let me illustrate this with a simple example, right? Let's say you as an end user, you try to look for a server in your organization. So you head on to your file or folders and you type in the server name right here and you try to look for the server, and what Windows does or what Microsoft, what the operating system does is it asks the DNS server for the location of this particular server. That's something we know already, right? But when DNS is not able to resolve the server's name, what DNS does is it asks LLMNR or an NBTNS server for the location of the server. So LLMNR is essentially a backup for your DNS server. So if your DNS server cannot resolve a host name, it asks LLMNR for the host name. And once LLMNR is being poisoned, right? So we poisoned LLMNR here by running the script, as you can see, right? So DNS has failed to locate the server name. So DNS asks LLMNR and we poison LLMNR right here. And as an attacker, I will tell the user that, hey, I'm the host, connect to me. And when that happens, the victim user who's trying to look for a server, right, his or her hashes will be dumped to the sniffer that we've been running all this while. So that is how this attack works. We poisoned LLMNR requests. So whenever DNS fails to locate a host, right, if the host is non-existent on the domain, DNS will ask LLMNR for it. And since we poisoned it, we pretend to be the host, and the victim's hashes or the victim's password hashes are dumped to our system where we have a sniffer setup, where we have a network sniffer setup, right? So in order to detect this, Log360 can help you, because Log360 can identify if there are malicious sniffer scripts that are being run across your endpoints. And not just that, you can configure a script in Log360, right? You can configure a custom script that checks for all LLMNR requests. Right? So if an LLMNR request is done for a host name that is not existing on your domain, right? And LLMNR returns a value saying, yes, there is a host name. It could be a potential attack attempt. So you could configure a script that checks for NBTNS or LLMNR requests for non-existent host names. And if one returns, it's likely spoofed, right? And you can set up an alert for that as well. So this is how Log360 can help you detect NBTNS poisoning. Last but not the least, the final attack that we've got here is the Twitter privilege abuse attack. Right? We've heard of the Twitter attack that has happened, and we saw that many accounts, such as that of celebrity accounts such as Elon Musk or Apple, there were cryptocurrency scams pushed out from the handles of these accounts. And the reason the Twitter breach happened is because of this. Hackers socially engineered a group of Twitter employees working within Twitter, and hackers were able to obtain access to the credentials of an administrative tool within Twitter or a privileged tool within Twitter, right? So this privileged system had direct access to Active Directory accounts. So this is how the attack happened. A hacker somehow got access, administrative access to the admin tool that was directly responsible for managing Twitter accounts. And that's the end of story, right? That's how the Twitter hack happened. And the two major reasons the Twitter hack happened is because of this. First, there was broad access to the administrator server, right? As I told you, hackers were able to socially engineer a group of employees to obtain access to the admin server. And the reason this attack was successful was because hackers, right, were able to find out many employees that had broad access to the administrator server, which should not happen. Privileged servers should only be handled by authorized user, but in Twitter, that was not the case. Right? So simple social engineering attempt got the hacker to gain the credentials to the admin server that we just saw. And the second mistake that happened was that the administrative activities were not monitored. The first mistake was broad access to the admin server. That's how the hacker got the initial access. The second mistake was administrative activities that happened from the privileged server, right? Such as passwords being reset for Twitter handles, log on to the admin panel, things like that. They have to be monitored, but they weren't monitored by Twitter as well. This is how Log360 can help you by looking into the privileged access in your environment, right? So Log360 can look into your group membership. So if you've got security groups, such as your administrators group or domain admins group that has direct access to a privileged server, Log360 can check those group memberships. Log360 can also check for nested or indirect group memberships and alert you if there is a membership change, if a user has been added to the group or removed from the group. Sometimes end users end up getting explicit rights on a particular privileged server in an organization. For example, in Active Directory, if I head on to my VM, right, and I open up my ADUC tool right here, and if I head into computers, right, so this is my VM. This is my computer right here, and an end user can get access on a particular OU or on a particular user when you delegate control to the user. Right? This is one way of delegating administrative access to end users in Active Directory. But another way to do it is to right click on the OU or the security objects, head into properties, head into security, and explicitly give access to the end user. So I can add my end user here. Let's say Ross. So Ross happens to be my end user here, who's got full control over this OU. This is another way explicit permissions can be given to users. Right? And Log360 can help you with that as well by monitoring explicit permission changes to your user objects. Right? So let me quickly show you how we can help without talking too much. If I head into AD Audit Plus and reports, right, you can see that we've got something called group management here that will show you members of groups when added, when removed, right? Or even when explicit permissions are granted to organizational units or users or groups. So if I give a user the reset password privilege on an OU explicitly, not via the delegation control wizard, all those permission changes will be monitored here, right? Another way users can receive privileged access is by group policy setting changes. That's right. So your group policies have a lot of changes. For example, if I head on to my group policies and head into user rights assignment, you can see that there are many group policies that your users can be given privileged rights from. For example, if I give in this right, my user will be allowed to log on via remote desktop services. If I give my user backup files and directories right here, my user can override any administrative privileges and backup files and folders within my organization, right? So there are many, many ways group policies can be leveraged to give users privilege rights, and AD Audit Plus can track those as well. right? So these are different ways your end users may end up getting privileged access to your privileged servers in your organization, which is exactly what happened with the Twitter attack. And AD Audit Plus can track all of those changes. And not just that, AD Audit Plus can also track for changes on once administrative access is granted to users. Right? For example, if a user resets a password for another user, AD Audit Plus can track those changes. If an administrative user is created in an administrative or a privileged group, AD Audit Plus can track those changes, and it just doesn't end there. AD Audit Plus can mitigate the actions as well, right? So let me quickly show you an example right here. If I head into configuration and head into create alert profile, I can create an alert right here, right? Across Active Directory, across Azure Active Directory, across my files or folders, such as my NetApp, EMC, the list simply goes on. I can create alerts for all of them, and I can also execute a mitigation action to basically disable the user's account or terminate the user who is performing a potential attack. Right? So not just admin privileges or privileges granted to your end users, Log360 can also help mitigate the privileges, right? So if there is a privilege granted to a user and the user was not supposed to have the privilege, Log360 will immediately alert you on that and also run a mitigation action. So that's one thing Log360 can do, and Log360 can also track the actions that are performed by your delegated or your privileged users. So quick summary of what we saw today. I understand that we went in a little too deep into many attacks that happened in 2020, but this was necessary for us because this will help us build our security, and this will help us avoid and detect any misconfigurations that are happening in our environment. Right, so we took a look at different attacks, the NTT server breach. We took a look at the ransomware attacks, such as the Snake ransomware or the coronavirus ransomware. We took a look at the San Francisco airport hack. We took a look at the Twitter hack, and we saw how these breaches happened and the misconfigurations due to which these breaches happened, or misconfigurations that led to the spread of the breach, the faster spread of the breach. And we used Log360 to help monitor or audit such critical misconfigurations that are happening on your domain, be it on-premises Active Directory, be it cloud such as AWS, Google Cloud, or Azure, and we were able to build customized alerts for that. And that's all we need to do to detect misconfigurations and fix them. Right? So that's about it. There's a lot that we discussed today. Please do not worry. A recording would be sent to you on your email post the webinar. So if you have any questions, you can always drop an email to me at rb@manageengine.com, and I would be more than happy to help you out. But before I end this session, a quick poll. Now you will find a question flash across your screen. Now this is just for our internal team. It would be really helpful if you could let me know your thoughts. So I will be launching the first poll right here. You will find a question flash across your screen. If you can just help me out with your thoughts, that would be really helpful. Thank you so much for your responses. Just a few seconds, and I promise I will be out of your hair, but please do not worry. The recording would be sent to you on your email. And if you have any questions, keep them coming using the Q&A tab. Of course, you've got my email ID as well. Just a few seconds, and I promise I will be out of your hair. Thank you for your responses. Now I do see a few questions coming. Please do not worry. I will be getting back to them in a few minutes now. I would love to hear your thoughts. I hope you found this session informative. I hope you found the breakdown of all the attacks that have happened in 2020 a bit useful, and I would love to hear what you think. Thank you for your responses. Thank you so much. Thank you. Just a few seconds, guys, and I promise I will be out of your hair. All right, perfect. Looks like we are done. And I see a couple of questions coming in, probably one question. And please do not worry, James, I will be reaching out to you on your email with a detailed answer along with screenshots if possible. So I guess that would help you out. And if you have any further questions, please do not worry, just drop an email to me at rb@manageengine.com and I would be more than happy to help you out anytime, right? For those of you who've reached out to me with your questions, please do not worry. I will be reaching out to you with a reply on your personal email just within a few minutes post the webinar session. All right. So yes, thank you so much for attending. I hope you found the session informative and I hope you have a nice day today.